Why do we need to convert text into a numerical representation? Because computer can't understand text. They understand only numbers. For AI models, we do everything based on predictions, and these predictions depend on numerical inputs we provide to them. The efficiency of these inputs determines the accuracy of the model. For different tasks, we need to modify these inputs by understanding the problem we are going to solve. One of the most popular methods for this is bag of words representation. For this, we take the whole corpus and save the word in a dictionary, providing them a unique ID. This method, as you can see in many tutorials of the NLTK library, converts text to tokens after tokenization, lemnization, and another process via NLTK. And these tokens are then saved in a dictionary-like object. Then we feed the text getting the tokens or IDs from this dictionary. This method has lots of disadvantages. One is only the placement of words information it provides. Means the model only learns what word is placed after what word or words and make a prediction on it. It loses much useful insight like part of speech, syntax, semantics, and word information like morphology and lexical information. This means word like suit have many different meaning, but in this method it gained only a single token for this, so the information of its meaning within the sentence is lost. For a single task, a large corpus is needed, so the size of the dictionary gets increased and the whole computation gets expensive. sklearn feature extraction text count vectorizer is a good example of this. You can read about it. This module converts the token information into a one hot vector, but the concept of this remains the same as we discussed. Manual feature extraction is a very unpractical method where researchers write algorithms that extract feature via some predefined set of rules based on statistical analysis. These methods provide a few benefits over the previous bag of words method, but overall performance is not so good. For this, expert level knowledge is needed to write these rules, and for a large corpus, it's very time consuming and expensive to study and understand, making it nearly impossible to write a set of rules that works for a real time data. When manual feature extraction failed, researchers thought, why not model extract features while in training as they do in vision problem with the help of convolutional layers? So they introduced a concept called model embedding that also gets learned while in training and converges to a perfect vector related to the text. This approach successfully overcome the challenges that previous method failed to solve, but it creates some new challenges. One is that its computational cost gets higher as the system needs to work on the embeddings part too. Second, it needs a large corpus to train, and training can take months or years to finish. We use the torch.nn embeddings module for this. Read about this and look at its use cases on the internet. To solve the previous problem, researchers thought to train the embedding over a large corpus and save them so that these embeddings could be used later. Such embeddings improve the efficiency of the model in many cases, but it also has limitations as they depend on the corpus they train. During the period of time when researchers tried to solve more complex problems, these embeddings didn't provide much benefit. Glove and FastText are examples of these embeddings. Read about these on the internet. Now there are numerous models that are trained on a very large corpus and have modern real-time implementation. These models embeddings can be used. The Flare Python library facilitates getting the pre-trained embeddings from one or two layers before the final output of the model. Using such embeddings helps resolve all the challenges we discussed. Read about the FAIR library to see example of how to get embeddings from the pre-trained models. And that concludes the discussion. Please accept my gratitude for your time and consideration. Thank you.